So, hello everyone. Myself Harshwardhan Patil, and first of all, I would like to thank Computer Science and Information Technology Journal, 9th International Conference, to accept our paper. And my topic is prognosis of Indian stock price through machine learning algorithm and sentiment analysis. So this will be our flow. We will be begin with abstract introduction, methodology, and then we will go with the problem statement, literature survey, existing system, proposed system, data set, experimentation results, and finally concluding and therefore the references. So yeah, as unpredictable stock prices forecasting is a difficult task due to the market's flexible and unconditional volatile nature. There is an increased computational capability software-based statistical medium of prognosis and inventive methods of prognosticating the model are combined by many researchers around the world. Sentiment along the quantitative methods are hidden history behind the stock price predictions. This gives the curiosity to find the best model for predicting the next 7-day closing price that will include polarity sentiment and the selected machine learning models. So here, introduction, we have basically taken our National Stock Exchange data set for experimentation. That is an Indian stock price data set. Basically, India has a National Stock Exchange and a Bombay Stock Exchange. And its nature of a routine is different than that of the other like New York Stock Exchange, S&P, which run 24 by 7 hours, whereas the Indian stock market runs from 10 a.m. to 3 p.m. So the stock market plays a vital role in country's economic growth as well as the individual economy to a large extent. Finding the right time to buy or sell the shares is depend on predicting the trends in the stock market. The technique for most accurate prediction is to learn from the past instances and design a model by using traditional and machine learning algorithms. The stock market trend varies due to the several factors, such as country's political factor, economic factor, environmental factor, society factor. The current trend is booming with the algorithmic trading as it is taking boom in the stock market world. Using this machine learning technique and sentiment analysis, it is beneficial to the traders to generate more profit and minimize their losses. So in the methodology, we have basically information of the two firms that we have experimented are generated from Yahoo Finance. Then the price points such as the parameters low or what low, close, high, open price, adjacent price, and the volume has been taken into the consideration. The sentiment polarity factor on news article has been taken, and the data set consists of 46 days worth of quantitative data, and then the comparison of random forest linear regression and root mean square error has been taken from the comparison of these three algorithms. The data is Tata Motors and State Bank of India. These are the firms which are listed IPOs of the Indian stock market in National Stock Exchange, and both are the giant in their particular sectors. Now here is the problem statement that we have defined that to study and apply the machine learning algorithm and polarity sentiment analysis for Indian stock price prediction and predict the next 7-day closing price of NSE listed stock. The literature survey, we have basically referred the varied papers with the same domain. And here is the analysis of various machine learning algorithm and hybrid model for stock market prediction using Python. Here, New York Stock Exchange dataset has been used and the comparative examination was done. The linear regression models here are put forth that significantly reduces the error. The summary that LN scale conjugate gradient and racial regularization techniques are used. Here, SBM predicted most deviated results from actual with the 60% accuracy. The second paper is the stock prediction with random and LSTM. So here, National Stock Exchange data set has been used and LSTM model has predicted better results and more reports has Here the statement has been incorporated that more reports if you use, then the better is the root mean square error we get. The decision tree approach has been used for the portfolio management. So observe the overfitting on training data, and this is the drawback. The LSTM has advantage over random forest. It's been concluded by the author. Then Indian stock market prediction using artificial neural networks on big data. Here, National Stock Exchange dataset has been used. ANN predicted with 0.30 as a root mean square error performance evaluation. Variation in the random forest model was observed here also. So in the summary, experimentation performed on these three stocks, use of artificial neural network for prediction, and there the random forest RMSE root mean square error gave 9.76, which is much more derivative than ANN. Then stock market prediction using sentiment analysis and deep learning. Here, National Stock Exchange data set has been taken into consideration. Predicted price were based on the random forest LSTM on K nearest neighbor. The one quarter data set has been used, one financial quarter data set has been used by them, that is of 3 months. Then sentiment analysis results deviated from the actual market trend. And here the Twitter API was used by the author for fetching the article. The existing system that has been considered is the stock price prediction using sentiment analysis and deep learning. The author is Narayana Bhumipani. Here the predicted price based on LSTM random forest and K nearest neighbor was taken, and one quarter data set was used. The two stocks, TCS and HDFC banks, were used here, and the sentiment analysis results deviated from the market prediction used of the random forest regression. So this is the proposed methodology. In our experiment, we have done the quantitative analysis and the sentiment analysis. For quantitative analysis, we have compared LSTM, linear regression, and random forest. And based on that, we have predicted the price and the trend in the prediction, which given root square error listed. And for sentiment analysis, we have used the polarity factor, and that is the trends and the news related to the stock that has been positioned in the market, and blogs and the Twitter sentiments has been categorized, and the keywords has been taken from that. So positive, negative, neutral, and the negative polarity factor has been taken into consideration. The data set that we have used is the National Stock Exchange data set, fetched from the Yahoo Finance, and wider sentiment analysis has been considered for fetching out the sentiments, and the Google News API and Twitter API were used for the sentiment. So data fetched from Yahoo Finance for National Stock Exchange, and then the wider sentiment for Google News for a news article has been taken into consideration. For experiment, we use stock exchange data for SBIN and Tata Motors of an Indian company in order to compare the three models. The data set spans 24 January to 27th of the July of the 2022. It's a recent data. It contains the daily stock prices, low and high values, as well as the total volume of the turnover of the traded stocks. System generated data set contains a day-wise open, high, close, adjacent, low, and volume traded price for the past 2 years. The random forest here is the overall method of the random forest that has they have picked the end random records. Based on the end records, they have built a decision tree from the algorithm, which choose the number of trees and repeat the steps 1 and 2. And then in case configuration problem for a new record, each tree in the forest predicts the value for the tree. For linear regression, it comes under the simplest type of supervised learning. It finds the pattern in the data and shows the prediction. Here y equals w1 into x plus b1, and y is the predicted value and x is the input that is given. Here the closing price was the input that was given from the historical data, and w1 is the slope and b is the bias. Coming to the long short-term memory, LSTM. LSTMs are basically the recurrent neural network that learns to predict from the future the sequences of variable lengths. The name LSTM refers to the analogy that the standard RNA is both long-term memory and short-term memory. Only important parameters are considered in a sequence and the rest are affected. Gates are the backbone of LSTM. Here, 50 units, that is the neuron concept, per layer used for the experimentation. The connection, weight, and biases in the network change once per episode training, analogous to how psychological changes and synaptic strengths store in long-term memories. The activation pattern in the network change once per time step, analogous to how the moment-to-moment change in the electric medium patterns in the brain store the short-term memories. So here is the overall the data collection. The data has been collected that on the collection of the stocks from Yahoo Finance, sentiment data from Google News, and wider sentiment. Then data pre-processing was done on quant data. Stopward removal was performed on the news article of the stock, and quant analysis use of random forest and linear regression LSTM model was performed on pre-processed data. And then the sentiment analysis was done for getting the probability score of sentiment obtained from the news article of the stock. And the predictive analysis is performed to predict the trend of the momentum of a particular stock for the next 7 days closing price prediction. So the performance metrics that we have used here is the root mean squared error. This is a standard deviation of the prediction errors. Residuals are the measures of how far from the regression line the data points are. Basically, the lower the root mean square error, better is the accuracy. RMSE is a measure of how spread these residuals. In other words, it tells you how concentrated the data is around the line of the best fit. And then the percentage change was taken to uniform overall the calculations. So it is basically the concept in math that represent the changes that have occurred over time. It is mostly applicable in the field of finance. It is the formula is actual price upon the predicted price and so on. And for sentiment analysis, we have used the polarity factor. That's it. So the positive will be when the polarity factor of positive to minus the this is the formula that polarity factor of negative upon polarity factor of negative is greater than threshold. Then the polarity will be the positive and the sentiment indicates the positive behavior. And vice versa in the negative. While if the polarity factor of negative minus the polarity factor of positive upon the polarity factor of positive is greater than 40%, sure, then it's a negative. Otherwise, it will be the neutral. So the two sources they are Tata Motors were considered for experimentation purpose. So here, if we see the analysis of the Tata Motors comparatively, LSTM has performed the best LSTM with a 3.3 root mean square linear regression with the 3.57 and followed by the random forest as a 6.15 RMSE. The average percentage was minus 1% in LSTM. In between, if you see this line, there was a much more deviation from the actual price and predicted price. And also here, uh, the linear regression has seen minus 3% change and there was only 3% change observed in the random forest. This is the sentiment analysis for the past 128 days. The sentiments were analyzed by the system. 78% positive score said that investors are good for the stock, and it followed the trend between the July of our experimentation. Trend of positivity is observed in actual as well as prediction for 128 days time series. Here, the overall table just depicts the root mean square error and the percentage change that we have observed in the previous slide. The LSTM is 3.13 and linear regression has RMSE 3.57 and random forest is 6.16. So here we say that the LSTM has performed better the stock compared to the other two models. In the polarity factor wise, there was a positive sentiment, 78% as a positive sentiment, and 22% was the negative sentiment, and there was a 4% of the negative sentiment. The SBI comparison says that here also the LSTM performed the best with LSTM root mean square error was 1.83. Linear regression was 2.27 root mean square error, and random forest was 4.86 root mean square error. The average percent change that was observed for LSTM for SBI was 1%, and that of linear regression was -3%, and the random forest was 10%, which has a much more variation. Says coming to the sentiment analysis performed on SBI stock, so 85% of the positive forces that the investors are bullish for the stocks, and the trend of positivity was actually observed as well as in the prediction for 128 days time series. So here is the summary of the experimentation for SBI. Here also the long short-term memory has performed better, and with the positive sentiment 85%, and the negative was 10%, and neutral was 5%. So here we will distinguish root mean squared error performance metrics on Tata and SBI. Even the prediction was the LSTM hold the least root mean squared error compared to the random forest and linear regression. Least percentage was observed in long short-term memory prediction. Random forest was much more deviating the variation of the actual and the predicted price for the compared model, and the polarity score for the sentiment analysis on the stock was positive sentiment for 85 and 78% respectively was observed for SBI and Tata Motors. Concluding to the overall experimentation, their variations are there in the actual and the predicted price observed during the experiment. It's not that the model has predicted accurately. LSTM can be effectively used to predict all stock prices. The results of the sentiment analysis about SBI and Tata Motors predict the positive polarity about both the stocks, positive polarity factors with 85% and 75%. This shows that the bull side will be the stronger for the stocks in upcoming days. The price action prediction of the stock is still a challenge. It presents the complete accuracy in the prediction. The root mean squared error performance measure is effective for comparison of algorithms. Momentum in the stock price is was actually the positive trend that was observed. We concluded. Now open for questions. Thank you.